See if I have anybody come. I'm being recorded. Anybody have questions from homework stuff, which you all are doing? You're all doing it. If you didn't do chapter 6 yet, you just say, nah, I'll go back and do that sometime later because I got to get into 7.1 right now. So just drop what you're doing anywhere else and just get into 7.1 so you can keep up with what's happening right now. That's always the most important. Thanks, Alex. All right, so no questions on anything? I love it. Okay. So let me see. Let me turn this guy off. Well, which part do I want to do? Okay. Maybe I'll turn this guy off. Bye, tree. All right. So if you have no questions, I'm not even going to review then. You got no questions. We're going to jump right into new stuff. So the very first thing I want you to do, let me share my screen then. Let me see, what's the best way to do this? Oh, here's somebody. Oh, here's somebody else. Here they all come now. Anybody else? I'm considering, guys, setting a password for the classes. Because right now I put you in a waiting room, and so when I see you, I let you in. So right now somebody's in the waiting room, I'm gonna let them in. And that kind of sucks. If I made a password, then I could feel more confident that it's just my students coming in, because I'm sure you guys have heard of Zoom bombing. Did we talk about Zoom bombing? Yeah, one of my colleagues had some inappropriate images up on her screen from somebody who had hacked into her, not really hacked in, but they just got into her Zoom and started sharing their screen, all this horrible stuff. So she had to shut the class down. It's a big problem. So that's why I put the waiting room in, but it's annoying trying to watch the waiting room as I'm trying to teach to let people in as they come in late. So maybe I'll do a password instead. That way I don't have to put you in a waiting room. You can just come on in with a password. I might do that starting next week. So here, let me share this. If you go to Math 90's Canvas, do you guys see the Math 90 Canvas?
Yes.
Yes, thank you. I'm never sure of this thing. If you go to the pages, you'll see right here, handout on 7.2. We're going to be working on that today. So one side of it is actually this side. We did this side last time. Hopefully this looks somewhat familiar. This is the last problem we did last time, if I remember correctly. So on the other side, there's this. So if you're able to, it might be a good idea to go to Canvas, take a look at this, or you can just look at your screen I'm sharing with you. So very first thing I want you to do, let me hide some of this other stuff. This problem right here, this very first problem, we're starting to get into the process for factoring trinomials. So remember, when is it that we use the grouping method? What is it that tells me to use grouping method? Does anybody remember? Because I'm not going to say use grouping. I'm not, because I'm an asshole. When do I know to use grouping? Does anybody remember?
And there's more than 3 terms?
Yeah, 4 or more. I love it. So more than 3 is one way to say it, or 4 or more. I love it. So you have a more efficient way of saying it. Yes. So when there's more than 3 terms, you try grouping. Today we're going to get into, well, what the hell do I do when there's 3 terms? What do I do? So we are taking baby steps in that direction. So there is a very weird, not weird, but like it doesn't make sense immediately why this has anything to do with anything. But just do this for me. I'm trying not to give too much away here. Here we go. Can you guys see that problem? It says 24 and 11 right there, right? I'm guessing so. Okay. So what I want you to do is just figure out, and this is almost, I could have asked you this on day 1, just to kind of play with numbers a bit, right? Can you figure out, don't say this, don't chat it, don't say anything. You just take a second. Here comes more people. My goodness. Can you figure out 2 numbers that multiply to be 24 but add to be 11? Don't say it. Don't type it. Can you think of 2 numbers that multiply to be 24 and add to be 11? Think about it for a minute. Sorry. Okay. Who's got that? Anybody figured it out?
3 and 8.
Yes.
3 times 8 is 24, and then 3 plus 8 is 11.
Kick ass. Do you guys get the idea now? Does anybody not get the idea of these kind of things? I need 2 numbers. Because what 2 numbers multiply to be 24? 4 and 6 do. But do they add to be 11? Nope. Right? 2 and 12 multiply between, they don't add to be 11. Damn. But 3 and 8, they do both. So try part B. Don't say anything out loud. Just try. Come up with 2 numbers that multiply to be negative 40. And they also have to add to 6. So just really think about it. Curtis, you all right? You say no. So negative. So the 2 numbers, they have to multiply to be negative 40 and add to be 6. What was about what you said earlier? Melissa, I didn't say give it away yet. That's all right. She just couldn't hold back. I understand enthusiasm. So yes, right. So now watch, stay with me. This, I don't know what this feels like for you. Isn't it, this is just playing with numbers right now. You guys kind of with me and you're like, this is not what I would choose to do, you know, around lunchtime on a Monday, but what the hell, I could do this. Just play with numbers, right? This will have direct, immediate uses in the factoring method we use. And we're going to see why. But I got to first start here. Just can we handle just playing with numbers? So yes, something to notice. If they multiply to be negative 40, don't they have to be different signs? Of course, right? The only way you can multiply 2 numbers to come out negative is if only one of them is negative. So you can't have them both positive. You can't have them both negative. And so to add to be 6, do you guys see how that means that the bigger number has to be positive? I don't know. Are you guys semi with me? Maybe I'll make another problem up like this. Yeah, a little bit. Okay. So yeah, definitely 10 and negative 4. Do you see how they're 6 apart? Because they actually subtract to be 6 because you're adding numbers with opposite signs. So what if it would have been, instead of 6, what if it would have been negative 6? No, Jeff. What if they had to add it to be negative 6? You can do it, Jeff. There you go, buddy. Now move it. It's amazing. So 10 and negative 4, multiply by negative 40, add to be 6. What if they had to add to be negative 6? What would the 2 numbers be then? You could do it. You could tell me. It's okay. Did I scare you guys from saying anything? Or do you have no idea? I don't know what's going on out there.
Negative 10 and 4.
Yes. So there's still 6 apart. It's just that if I need the answer to be -6, then the bigger one has to be negative now. So still 10 and 4 because they're 6 apart, right? So if it's +6, then let me put that answer down here. The answer is 10 and -4. You can do it, Jeff. There we go. But if they had to add to -6, oh, I didn't delete that. Why don't you let me delete you? You little, I can't access you. Why? That's out. Okay. If they had to add to -6, then it would be -10 and 4. You still want to make 6. It's just that if you want to make +6, the bigger one's positive. If you want to make -6, the bigger one is negative. That's all. So let me make up another problem before we do this last one. What if I said I want 2 numbers that multiply to 48 and add to be 19? Don't say anything out loud. Think about it. You can use a calculator if you have them. Use them if you got them. They have to multiply to 48 and add to be 19. Don't say anything out loud. And just go with this for right now. I know I don't know what you're thinking right now about what we're doing. You have to trust me. This will come in handy very, 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 very soon. So one way to do this, there's a lot of ways to break up 48, right? So you can think 8 and 6, but they don't add to be 19. Damn. So let me start off with, well, no. I know somebody has the answer. Don't tell me yet. I know you do. Don't worry. You'll get credit. You got some brownie points. I know you get the answer. But now watch. The unfortunate thing is if you've ever been taught this way of factoring, a lot of times teachers get so stuck on making the multiply thing first, and that is bullshit. Why don't I start this way? What adds to be 19? Like, don't 5 and 14 add to be 19, right? Yes, but what's 5 times 14? Is it 90? 0 to 70, Jeff. Oh boy, what a great day for Jeff. Right, 5 times 14 is 70. You guys with me? So that doesn't work, does it? That's crap. Let me draw a line through it. Get out of here, you crap. Let me see. Yeah. Stay with me now, stay with me. So 5 and 14 did not work. So let me try 4 and 15. What do they multiply to be? What's 4 times 50? 4 and 15 make 19, don't they? Don't they? Again, don't forget, this feels like a little, let's just take a break from our normal weird algebra shit, and let's just talk about numbers just for a minute. Yeah, 4 and 15 add to be 19, and like Curtis says, they multiply to be 60. Have I gotten closer? What was it I wanted them to multiply to be? I want them to multiply to be 48, right? So 5 and 14 didn't work, and then I made it 4 and 15. So let me try 3 and 16. Don't 3 and 16 still add to be 19? And I noticed the pattern was 5 and 14 was too big, right? It made 70. 4 and 15 makes 60. I'm getting closer. So what's 3 times 16? All right, I'm going to go with youngsters shaking their head. It's 48. I don't know why nobody's helping me out. So those are the two numbers, 3 and 16 are the ones that work. And do you see how I sort of just played around with the possibilities to get to it? So 48, I thought 8 and 16. You could think 12 and 4, and you're like, ah, shit, I don't know anymore. So then you go to 19 instead. What adds to be 19? 5 and 14 add to be 19, but they don't multiply the right way. 4 and 15, I got closer. 3 and 16, that's the answer. It's like a Price is Right, higher, lower thing. I have no idea how you guys feel about that. All right, so some of you guys might have realized that 48 is 3 times 16, but when I say factor 48, how many of us think 3 and 16 like that? Not many, right? Okay, so let's try this last one. Let's see what this last one is. See how weird this is. Yeah, so take a minute. Don't say anything yet. Don't type, don't say anything. I want two numbers that multiply to be negative 56, but they have to add to be just 1. Don't type anything, don't say anything. Think about it. What am I doing with my hand? I don't know. Think about it. Oh, add to be -1. Thanks, Curtis. You're right. I was like, why is he writing -1? I think I said 1. You're right. Has to be add to be -1. I don't know which way it looks right to you. So anybody got it figured out?
7 and -8.
Yeah, so the cool thing is, so a couple things, do you guys realize, so if the two numbers have to multiply to be negative, one of them has to be negative. Then when you add them, you're really subtracting them. Do you see what I mean? If one of the numbers is negative, when you add them together, you're really subtracting them, aren't you? When I add 5 and -4, that is 5 minus 4. I am subtracting them. So I want them to multiply by -56 and be 1 apart from each other. So that's definitely 7 and 8. And to be negative as a result of adding, the bigger one's got to be negative. All right, let's do another one. So let's say add to what, Jeff? Well, let's start with this. Multiply to, you can do it, buddy. Can you? Can you do it? Yeah, sure. Multiply to negative. Yeah, we'll do this one. Add to 7. Don't say anything out loud. Don't type it. Just think about it for a minute. I want two numbers that multiplies to be -60 and adds to 7. Don't go against the family. All right. I'm going to make a problem up here for a minute. Let's see. Nah, won't do that to you. Okay, who's got the answer? Anybody? Anybody?
-12 and 5.
Yes, so 12 times 5 is 60, and 12 and 5 are 7 apart, and the bigger one has to be positive. I can't remember what you said now. So yeah, -5 and 12. All right, I have no idea how you feel about this. Thankfully, you can use calculators, but you should be able to play around with numbers to this degree. Okay, maybe. All right, so let's see. Here's the next thing. And this is going back a little bit in time. So that first step was just to make sure you can play with numbers. Just do these real quick for me. You guys can see these problems? Oops, let me see if I can zoom out one more. See those 4 problems right there, the foiling problems? Just do those. This will be a nice trip down memory lane. Let me push this up a little bit. These problems right here, just do them for me real quick, and then I'll see if 4 different people can tell me the answers. let me jump in real quick just to show you something to think about while you're doing the other ones. Hopefully, you guys got the first one going. So to do this, of course, I'm going to distribute the x and then distribute the 4. So you should get x squared plus 5x plus 4x plus 20, right? And of course, what can you do then? You can combine the middle terms, right? Now, answer me this. Riddle me this. That 20, what parts of the original problem did that 20 come from?
4 and 5.
4 times 5. And where'd the 9 come from?
4 plus 5.
4 plus 5. Doesn't that sound a lot like what this was up here?
Yes.
4 and 5 are 2 numbers that multiply to be 20 and add to be 9. Do you guys see that? Now keep going. Do the next one and pay attention to that kind of thing. Look at your results and see where those came from. So actually, I already know. Can you see how to do this? Now it's a nice way to do this quick. This will be x squared. The middle term would be 2 plus 8, x. And then the last term would be 2 times 8. Right? Now, this isn't just a shortcut for foiling, right? It isn't. It's actually a beautiful way to look at it to go backwards now. What about this one here? And if you don't like the shortcut, don't do the shortcut. Do part C either way you want to. Go ahead and do part C real quick. Maybe do it all the way out. Do the FOIL thing just to really make sure it still works. There's some negative stuff in there now. Who knows? The negatives always mess things up. Damn you negatives, we should have never made you. Then I would never have been in debt. Why did we invent negative? Damn. We had such a great opportunity. All right, so let's see. So when you FOIL this out, you get x squared, and then the x goes times -2, so -2x. Then the -6 gets a turn. -6 times x is -6x, and -6 times -2 is +12. Oops, somebody's here. Let me put a little spacing in there so you can see this better. So then I can put together my middle terms, x squared minus 8x plus 12. And sure enough, where'd 12 come from? -6 times -2. Where'd -8 come from? -6 plus -2. So what 2 numbers add to be -8 and multiply to be 12? -6, -2. Do you see? Do you start to see how if they gave me this, I could figure out where it must have come from because now we see the pattern. A big part of mathematics is observing a pattern and then using that pattern to do things quicker or to create these processes to do things just by observing patterns. And real quick, this last one here, right? X times x, x squared. And then x times 7 is plus 7x. Is that a -4? Dadgummit. Yeah. And then -4 times x is -4x. And then -4 times 7 is -28. So then I get x squared plus 3x minus 28. So again, 7 minus 4 is 3. That makes the middle when you combine them. 7 times -4 is -28. That makes the last number when you multiply them. So the whole idea of 2 numbers that multiply to be something and then add to be something. So for example, this problem right here. I'm going to try to not show too much. There we go. Perfect. Oh, shoot. I'm showing too much. X squared plus 7x plus 12. This problem right here, right? What 2 numbers add to be 7 but multiply to be 12?
4 and 3.
4 and 3. And now watch. What two numbers multiply to be x squared? Or what two things? That's kind of a silly question. What two things multiply to x squared?
2 x's.
X times x. I love it. So now watch. Look how we break this down. This is how we factor this. X squared plus 7x plus 12 is x and x to make x squared. 4 and 3 to make 7 when you add them, 12 when you multiply them, because that's how distribution works, right? You'll get x squared plus 3x plus 4x. There's your 7. 4 times 3, there's your 12. So really the heart of doing these kind of, notice something real quick. Notice how they have to be in this form here for this to work. 1x squared plus something x plus something. And then maybe this process will work, right? So let's do this first one here together. And this process will always, if it's factorable, can you factor every number? No. So can you factor every polynomial? Nope. Some of them will be prime. So look at this first problem. I can write this down automatically. Let me see if I could do this in a way that's understandable. I can write x and x. That part I know. I want everybody to see. You guys see that? It's got to be x and x because I got x squared. That would be the first thing I do in my foiling, right, is x times x. The only thing I don't know are the two numbers at the end, but now I know a process to get them, right? What multiplies to be 12 and adds to be the middle, 8?
2 and 6.
Say again?
2 and 6.
2 and 6, exactly. 2 and 6 add to be 8, become a 2. And they multiply, dadgummit, in a half. No, not 6,000, Jeff. Give me a second. I love you, 3,000. Go away. So really, that whole first thing we did with playing around with the numbers, it's so you can fill in the only things you really don't know, the numbers at the end. I know the beginning is going to be x and x because it's got to make x squared. It's just the numbers at the end that I don't know, and I can get those by doing this kind of thing. So do part B. I'll wait. Don't say anything. Don't type anything. Just do part B. That is so weird. Why is that little red there? I don't know what that means. Oh well. That's so strange. Oh. So I want to point out a couple things as you're working on this. Can somebody tell me just this? Just tell me this. You need two numbers that multiply to be what?
-10 and a -2.
No. Yeah, no. Stop. Only answer this. You need two numbers that multiply to be what? Just so I can make sure everybody's
20.
20. Good, right? So you always think about what multiplies be the last term because that's where the last term comes from, isn't it? It's the one where you multiply the last things. So two numbers that multiply to be 20, and they have to add up to be -12. Now notice this real quick. And this is not a ton to remember. It's just the math trying to help you. If they multiply to be positive, can they be different signs? If two numbers multiply to be positive, can they be different signs?
Yes, but the one with the negative sign has to be the lower number.
No. If you multiply two numbers and they are positive, the result is positive, they cannot be different signs. What's negative times positive? Negative. What's positive times positive? Positive. What's negative times negative? Positive. So if the last number is positive, you either have both numbers negative or both numbers positive, right? Let me stop for a minute. You got to let me know the minute I lose you People always see this as a bunch of stuff to memorize. That is bullshit. These are things we know already. They should be something in the problem that are helping me out. So I know my two numbers are negative. I know both of them are negative. Already I know that because they have to multiply to be positive and add to be negative. The only way they can do that is if they're both negative. So if they're not opposite signs, that means they actually add to be 12. So I need two numbers that add to be 12. They're both going to be negative already. I know that. And multiply to be 20. So what Yansha said earlier, 10 and 2. So then I know it's going to be 10 and 2, and I know that they both have to be negative in order for the middle term to come out negative. Now, if at any time you don't believe me, you can just FOIL this thing out to check it. Oh, I don't know, Curtis. I'm sorry, buddy. Woo! Try a part C, and I'll give you a little hint. They have to be different signs on part C because they multiply by negative 60, right? So try to do part C now. And then I want to show you something kind of nifty. Oh, I'm not going to sing for you. That would be horrible. That would be cruel and unusual punishment if I sang. All right, guys. So I really, please, can you see that this step right here only makes total sense? That part right there. I'm not done yet, but I know it had to come from something times something where the first parts are x's because that's how I get x squared. So fundamentally then, the only thing I don't know at the beginning is what the numbers are at the end, and the whole thing about multiply and add to be, that's how I figure out what the numbers are. It's a puzzle, which I'm sorry if you hate puzzles, but if you love puzzles, that's what this is. It's a puzzle. So I already told you, I already gave this away. They have to be opposite signs, right? This one could be a little bit freaky because it's not the immediate way you think of to add to factor 60. So what I would do is this. Two numbers that add to be negative 11 that are different signs. So here, let me know if this makes no sense. So like negative, I'm not going to, oh, Randy's calling. Negative 13 and 2. Don't those, don't those, what am I trying to say? Don't those add to be negative 11, first off? Do you guys agree with me that negative 13 and 2 add to be negative 11? But when I multiply them, what do I get? I only get negative 26. Not big enough. So let me step it up. What about negative 14 and 3? No, become a negative. Do you have to do it the way I'm doing it right now? No. I'll show you another way in a minute, but I really like this way personally. What's negative 14 times 3? Unfortunately, it's not enough, right? It's negative 42. I want 60. So, but I'm getting closer. You guys see that? That's one piece that I love about this is you take a guess and you take another guess and you're like, I'm getting closer. I'll keep going the same direction. So let me go negative 15 and 4. And sure enough, we saw this earlier, negative 15 times 4 is negative 60. So that means those are the two numbers. That means I'm done. I just have to write them in. Those are the only two things I didn't know. So now I know it doesn't matter which one I put first. No, of course not. Because multiplication doesn't matter what order you multiply two things in, right? So you could say x minus 15 times x plus 4, or you could say x plus 4, x minus 15. Those are both the same answer. You guys cool with that? It's like somebody going, no, the answer is 7 times 5. No, man, the answer is 5 times 7. It's like, what the hell are you people doing? 5 times 7 and 7 times 5, same thing. Okay, maybe. Maybe? Yeah, okay. So let me do this. Let me go back to this one. This is not quite as gross. We're done with this problem, right? In fact, let me circle this. Let me make this. That was the answer. We're done with it. So, of course, Jeff can't leave it alone. Besides, Jeff can't draw an ellipse, I guess. Too bad. All right, I'm not going to be able to let that go. I'm sorry. Hold on. I can't even erase the damn thing. Screw it. It's going to stay. We've done this once before. What if X was, sure. What if X is 7? I'm doing extra shit right now. And this is the part that I hate about not being in a classroom is I cannot see how this is going over in your faces. I always kind of gauge what's happening with the looks in people's faces. I have nothing to go on now. Some of you guys are just pictures. So you got to speak up if something's really freaky. We're doing extra shit right now, right? Just like Jeff to do that. If X is 7, what is this number? That number would be 7 squared, 49, minus 12 times 7, 84, plus 20. You guys see that? X squared minus 12x plus 20 would be this number if X was 7. Why did I pick 7? I could have picked any damn thing. That's why, and 7 came to mind. 7's my lucky number. No, it's not really, actually. 7's not my lucky number. So let me
Can you
get that
say
out.
what you did again to get those numbers? So 7 squared is 49.
If X is 7, 7 squared is 49, 12 times 7 is 84, and then I got 20. That one I didn't have to get. It's just there, right? So what is X squared minus 12x plus 20? If X is 7, it's 49 minus 84 plus 20. And what is 49 plus minus 84 plus 20? It's negative 15. I'm pretty sure. I don't know. I did that kind of fast. Yes, it is. And again, this is all extra stuff. This is all extra stuff, but it is kind of cool. What could I have picked for X instead of 7? Anything in the universe. Anything. What about the square root of 18 billion and 7? Yeah. Why would you do that? But you could. Now watch. If X is 7, what are these numbers? What's X minus 2 if X is 7? X minus 2 if X is 7. If X is 7, what's X minus 2?
5.
5. And if X is 7, what's X minus 10?
Negative 3.
And what's 5 times negative 3?
Negative 15.
Yes. So if X, I really want you guys to understand this. If X is 7, then the original number is negative 15. And a way to factor negative 15 is 5 times negative 3, which is what the answer we got represents. So we actually did factor every number that looks like X squared minus 12x plus 20. You pick a number for X and you get what that number is. And then we factored every single one of them. How many of them? Infinite infinities of numbers. Holy shit. So considering that, it was really damn easy. Considering that we're doing an infinite number of infinite numbers. And it's actually more infinite than that, but let's not think about that. Holy macarones. Okay. So everything in blue up there, you do not have to worry about. It's just really nice if you understand it. Let me skip D for a second. Look at part E. Try part E right there, the one with the A's. A. We'll do part D in a minute. Let's see. Weird. That's weird. Okay. Trying to keep everybody up to date here. So let me do the first step here. So I can always, whenever there's a 1 out front, that's the important thing. I know it's going to be A and A in this case. Not X and X, obviously, because it's A squared. So it's A and A. That part is known before you do any work. I know that A times A makes A squared. That's remarkable, right? So to fill in the rest of this, I just need to figure out what two numbers multiply to be negative 72 and add to be negative 1. Since they add to be some kind of 1, they have to be 1 apart. So what two numbers multiply to be 72 and are 1 apart from each other? No? Do you guys know? What's 72 divided by 8?
9.
Yeah. So 8 and 9. But which one's going to be negative? They have to add up to be what? Look at the middle. They have to add up to be negative 1, right? Isn't that the middle coefficient?
Negative 9.
Yes, the bigger one has to be negative then. So this will be, you can put, it doesn't matter what order again. I'm not going to rewrite it every time. A plus 8, A minus 9, or the other way. It doesn't matter. As long as you got those two parts, right? You guys start to see this? This is kind of the absolute core of this problem is just a number puzzle. So would you choose to do a number puzzle just on a Saturday afternoon? No, probably not. But if you had to say you want an algebra problem that's got a lot of weird shit with trains and you have to set up your own distance equals rate times, or do you want something that's a number puzzle? You're going to pick the number puzzle. I know you. I would pick the damn number puzzle. What are you talking about? Real quick, what about F? If F is going to work, what do the two numbers have to do? Somebody hasn't really spoken up yet, tell me. Maybe I'll call on somebody and you won't really be there and I'll go cry somewhere. They don't want to come to my class. Anybody? What are the two things that the numbers have to do for part F? They have to multiply B.
Positive.
Be
7.
more specific. They have to multiply to be
Positive 7.
7 and add to be
Positive 3.
3. Now think about that. What's the only two numbers that multiply to be 7?
1 and 7.
Do they add to be 3?
No.
So this one, what would you call this then? What's a number that I can't factor? What do you call it?
A
Call
prime
it
number?
No, you call it prime, exactly. Just say prime. If you say can't be done or something like that, that's fine, but officially it's a prime number. Get out of there, stop it. This is not a prime, I gotta be careful. There could be values of M that make the number not prime. But there are no values for M that make it prime. So this variable expression cannot be factored. Not nicely anyway. I can't use whole numbers. I can't use nice whole numbers. You could factor it with really disgusting square root kind of expressions, which we're going to do later, but not right now. Right now we're dealing with integers, whole numbers and negatives, right? Thank the gods. So look at this first one. Does anyone see an issue with this first one based on a point I made earlier? What's got to be true for this method to work? What's not true about this that makes the method not really work? Anybody?
It would be 1 and 8, but it would have to be -1, but that would be a
No,
negative
no, no,
8.
no, 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 no. There's a part of this problem. So I didn't really make a huge deal out of this. But there's something that has to be true for this method to work. And let me show you up the top of this thing. It tells you what the form of it has to be. What's in front of the x squared?
So the first term has a coefficient.
It has to have a coefficient of 1, and this one has a coefficient of 2. So here's what's going to save you. So now that we're starting to learn more factoring methods, here's a really huge thing. Always try GCF first. Always. It'll save you from making mistakes or making a problem harder than it should be. Is there a GCF for part D? Is there a number that comes out of all three? Yeah.
2.
What is it? 2. So then what's left? X squared plus 4x plus 4. Now look at the inside. Look at what we just uncovered. Now get in there. 2x, right? The 2 is just coming for the ride. You guys see that? We've done a problem like that before. The 2 is just coming for the ride. But look inside. Look at this part. You need 2 numbers that add to be 4 and multiply to be 4. What's the only 2 numbers that do that?
2.
2 and 2. That's right. So then it's going to be, you almost can't go wrong. You put the 2 first, and then you put the 2 second. Not COVID. So yes, no matter what method we learn, you will always want to try GCF first. Sometimes it's the only thing you can do. And sometimes it makes the problem much easier. Now we are going to learn, will I always be able to factor something out if the first number is not 1? Nope. There will be situations where I got to, so we're going to learn a method to work with the first number not being 1, right? We're going to learn it, and it's going to be harder for sure. So if I can take that damn first number out, yes, I will, right? So as we learn more and more forms of factoring, you want to always try GCF first. I'm going to stop saying it. I've said it many, many times. In fact, on the sheet I will post that has all the forms of factoring on it, once we learn some more, the 0th step is GCF. It's such an important step. I make it the 0 step. Not even the first step, it's the 0th step. All right, I'll stop. Did I have more on here? No, let me make up another problem. What time we got? All right, we got a little bit more time. Here we go. Here's Jeff's bonus problems. Not bonus because they're hard. I'll make the first one nice. So factor this. X squared, yeah, let's make it nice. Plus 17x plus, what, Jeff? I don't know, man, 30. This is not too bad. Don't say anything, don't type anything, just try to do it. X squared plus 17x plus 30.
Prime?
Huh? What?
Gonna be prime?
It's not prime.
Okay.
Good try, though. By the way, in the homework and on the quizzes with factoring, I will sometimes put like one problem on there that's prime, but if you end up answering prime for like 5 of them, you're wrong, right? I'm not going to make that many prime answers, right? So be careful. So I need 2 numbers that do what?
Multiply to be 30 and add to be 17.
Yes, so it's always multiply to be the number by itself, and add to be the coefficient of the middle. So what multiplies to be 30? It can't be 3 and 10.
15 and 2.
Yeah, right, so you think 3 and 10, damn, 30 is even. 2 times what is 30? 2 times 15, and what's 2 plus 15? 17. So it really is a number puzzle. So those of you who unfortunately were not drilled with their multiplication tables enough and you just don't know your multiplication tables really well, this is going to suck. It really, really, really is. And I'm sorry. I wasn't there way when this all happened to you. Find your old teachers and slap them in the face if they did not make you memorize multiplication tables. Because humans should just know some basic multiplication. This might be good motivation to learn. Because the more you know, the quicker these will be. Because they are just number puzzles. Let me give you one more, and then I'll let us stop. Okay. Let me make one with some negative stuff going on. Let's see. Let's do something. Yeah, let's do something like that. That's pretty gross. Wait, I gotta. Ooh, that's gross. I like it. Ooh, yeah, that's awesome. Oh, that's evil. That's so evil. That's so evil. Wait a minute, guys. There. Okay. Look at it now. Look at it now. I made one change. So now it's possible. So this is not prime. So here's a suggestion. Do you see how big 288 is? How many factors does 288 have?
180.
Shh. Don't give the answer away. Is that what somebody who's going to be quiet? A lot. There you go, Curtis. So 288 has a lot of factors. If you try to make a list of them all, it would take all day. So let me start with -2. I just need, now I really want you to listen to me. If you've learned this before, I'm almost certain your teacher has never taught this. And I'm not saying I'm Mr. Amazing. I'm just saying I don't know why people don't do this more often. If the number that I'm supposed to multiply to get is huge with a lot of pieces to it, let me start with the number in the middle. I just need to end up with two numbers that do both things. Who cares what I make work first? So can you come up with two numbers that add to be -2? They're going to have to be different signs, which means they're actually going to have to be 2 apart. So let me start us off. Like 10 and 8. To add to be -2, the 10 would have to be negative. But what do they multiply to be?
-80.
-80. That's not anywhere near enough, right? So let's take a big step. That's nowhere near enough. So let me make the numbers bigger. -20 and 18. Don't they add to be -2? Yep. What's -20 times 18?
-360.
360. See now, let me stop for a minute. Do you see how I overshot the answer? It was 80, now it's 360. Oh shit, I'm past it. I overshot the answer a little bit. So let me take a step back. What about -18 and 16? Don't they add to be -2? Yes, they're still 2 apart. And the bigger one's still negative. What's -18 times 16?
288.
288. 288. Negative, yeah. So you could make a list of factors of 288. 2 times 144. 3 times whatever, I don't know. 3 times 96. 4 times 72. 5 times, no. 6, oh my God, that would take forever. You could do it though. It's up to you. You just need to find two numbers that do those two things. So I'm trying to give you ways to do that better when some of the numbers are big. So I got x minus 18 and x plus 16. It doesn't matter what order you do it in again. I just know that those are the two numbers that have to go at the end. You will cooperate. You will cooperate. You will cooperate, sort of. Oh my gosh. Come on, computer. Poor little computer. Okay. Ooh, wow. That's a good job, everybody. And don't forget, you can take any of the problems we've done, pick a value for x, see what the original was, and then the answer you got has to be a way to factor that. That's a way to check your work. right? Anytime you feel like it, which could be never, that's fine. It's not a part of what you got to do. All right. Is that enough? Let's see. Looks like you can go up or down 2 to get the answer based on negative 2. Yeah, Curtis, you just need 2 numbers that are 2 apart for the last problem we did, because I know they're going to be negative and positive. So then you can pick 5 and 7 and go, whoa, that's way too small. And then you just make them bigger. You can think 13 and 15, and you're like, well, that's not quite it yet. But now it's become sort of like you can at least see that you're getting closer to the answer, which you can't always do in math. Sometimes in math, you're like, I think it's this, and I have no idea. But here I think it's this, and I can see exactly how much I'm off by. I can see which way I'm supposed to go. Oh boy, so this is 7.2. You definitely want to get in there and try it out. What we're gonna go over tomorrow is some more of these, and then we're gonna get into, well, what if the first number, so we're gonna be able to do this tomorrow. We cannot possibly do this right now. We're going to be able to do this kind of problem. 4x squared minus 5x minus 6. We cannot do that using this method. Can anybody tell me why? We were able to do this one, right? It had a 2 there because I could take it out. What about that 4? Can I take that 4 out? No. And this process is so relatively simple because it only works when the first number is a 1. If that first number is not a 1, things get really interesting. Okay, so no matter where you are in the homework, I would definitely recommend you try some out of 7.2 so that you're ready with some specific questions tomorrow. Okay. Any questions? Anybody need to hang out for a bit? Anybody have questions or something? No. Okay. People are starting to leave. I'm going to pop some bubbles. When you leave, I see your little box disappeared, like popping bubbles. Pop. Come on. You're going to go. All right. Pop.
Will you be, you said initially that you were going to start doing quizzes from some of our previous work.
Oh yeah, the like review quiz stuff. Yes, I haven't really figured out when to insert those. That would be fair.
Do you have any worksheets or anything to practice on? I feel like I've got a good understanding of everything as we're doing it. I'm just a little concerned about going back. And
the absolute best place is your old practice tests.
Okay.
Right? Those are the absolute best place for like the immediate study guide kind of stuff. Because those are the kind of questions I like to ask. And then the next level after that would be all the quizzes we've taken and the tests we've taken themselves, right? And then the next place after that would be homework, but that's like, wow.
Okay.
But yeah.
Okay. Thank you.
Sure.
Bye.
Bye, guys.